variation. Direct variation. The equation that represents direct variation is y equals a times x. Okay? And direct variation is between y and x, where y varies directly with x. That means when x changes, y changes. Okay? When I plug something into x, that affects y. Okay? A constant of variation is the non-zero constant a. So a is called your constant of variation in this equation. So when they ask you to identify in a direct variation equation the constant of variation, it's always the number that's in front of x. It's always your a. Okay? So then we get to problems where we're going to graph. And it jumps right into writing a direct variation equation that has negative 4/8 as a solution. How can I write that equation, and then after I write it, we're actually going to graph it? How can I write an equation? What do you think I could do with that? See if we can think. What? Yes. No. Almost. So my equation says y equals a times x, right? So Tyler did a good job telling me 8 is y. What is negative 4? Is it my a or my x? It's my x. So I have 8 equals negative 4a. So when you are writing a direct variation equation, you're going to have a two-step process thing that you're doing. So I have to figure out what a is first. I divide by negative 4, and a comes out to be negative 2. That is not my equation. My equation is when I flip it back and say y equals negative 2x. This is your equation. That is what they are looking for. So when it says write a direct variation equation, you are literally solving for a, then you're plugging a back into the y equals ax form, and you have nothing plugged into y or to x. Does that make sense? So it says y equals negative 2x. Can you graph y equals negative 2x? Yes, I can graph it because I know a point already. What is a point on this graph? Negative 4/8. Okay, negative 4/8. So if I graph negative 4/8, then I know that my slope is what? What would be your slope in this one? Negative 2. Negative 2. Okay. So I'm going to go down to over 1. Down to over 1. And there's my graph of my line. So I can create an equation, I can graph it. Does that make sense so far? Okay? So that's what direct variation is. Direct variation only can happen when where my constant is being multiplied by my x and I get a result of y. Yes, correct. Okay? And when you are doing direct variation right now, direct variation never has anything added or subtracted or multiplied or divided onto it. It's literally this simple of an equation. Y equals a times x. Okay? If there's other stuff added to it or if things going on to it, it's no longer a direct variation formula. Okay? Because I didn't directly plug something in and get something out. I also did another step in between there. So it has to be, I plugged it in, I get it out. Okay? That's how direct variation works. So tell me how I would create an equation for direct variation with these numbers. I need an equation with 6, negative 2. What do you do? What would be my direct variation equation with 6, negative 2?
Negative 2. Well, you would solve for it first?
You would solve for what first?
A.
Yes, you have to solve for a first.
So you're going to go with negative 2 equals 6a.
Okay, negative 2 equals 6a.
And divide by 2. Divide by negative 2 on each side.
No.
And divide by 6.
Divide by 6 on each side, and a equals what? negative 2, 6, which reduces to what? 3. No,
1 over 3.
negative 1 over 3. You can have a fraction as your a. You can have a decimal as your a. Don't flip out if that happens. That is definitely okay. Now, how do I put that into an equation? If I wanted an equation, I can't just stop there. I have to do what?
Y equals
y equals
negative 1/3.
negative 1/3 x. There's my equation. Y equals negative 1/3 x. That is a direct variation equation. Okay. So then they give us word problems, okay? And it says hailstones form when strong updrafts support ice particles high in clouds, where water droplets freeze onto the particles. The diagram shows a hailstone at 2 different times during its formation. So one looks like this. One's large, and it says the diameter is question mark. Okay, and it tells me t equals 20 minutes. The other one is smaller, okay, and it tells me the diameter is 0.75 inches. Okay, and it tells me that t equals 12 minutes. Okay. Question A says, write an equation that gives the hailstone's diameter in inches after t minutes, if you assume the diameter varies directly with the hailstone. So, create an equation when the diameter varies directly with the time the hailstone takes to form. So, anybody have a guess of how we can put this together? Or have an idea of what we can do? So I want to create an equation when diameter varies directly with the time the hailstone takes to form. The diameter varies directly. How could I set that up? What? Go.
I was going to say you have 0.75, 12 minutes, 12 minutes would be your x.
Okay, you say 12 minutes is my x,
Yeah.
and you say 0.75 is my good, because it is diameter directly with time. So that means my time is now my x, and my diameter is now my y, because over here it says when y varies directly with x. So you got to pay attention to the wording, okay? So Tyler's right. I'm going to set up an equation that says 0.75 equals 12a. So then I have to take this and divide it by 12. What is 0.75 divided by 12?
What did you just set it up with 0.75 over 12 plus b over 20?
Give me a second, Isabel. We'll talk about that. What is 0.75 divided by 12?
0.0625.
0.0625. Now, my equation is, okay, my equation, because they asked me, and they asked me to use D and T, would be D equals 0.0625 times time. That is part A. That is my equation. Does that make sense? Do you understand how we matched it up? Isabel wanted to know if we could set up a proportion. Is that what you were asking me? You could, but because they want a direct variation equation, you have to do it this way. Because they want you to show that you can do it this way.
Why don't we just multiply that times
Why don't you just multiply what times t?
0.0625 times 20.
To get this diameter? Yes, and that's part 2. What is the diameter of the large hailstone? Tyler said all we're going to do is plug 20 in for t so that it says d equals 0.0625 times 20. And if I do that and multiply by 20, you get what? What'd you say? 1.25. You get 1.25 inches, and your answer has to be in inches. Okay? So that's a way that direct variation works through word problems. So you have to pay attention to how it's worded to know what stands for your y and what stands for your x. Okay? Okay, so now we're going to talk about the ratio thing as well. Okay, so now it says this. I'll read this whole problem in just a second, but let me write this chart on the board that we need to look at. So, tooth length of a shark, okay, and then the body length. We're going to compare these things and take a look at some stuff. So the tooth length is 1.8, body is 215. These are all in centimeters, both units. Okay, tooth length is 2.4, body is 290. Tooth is 2.9, body is 350. Tooth is 3.6, body is 430. Tooth is 4.7, and the last tooth is 5.8. This is 695. This is 565. Okay? And this is of a shark. And it says, great white sharks have triangular teeth. The table below gives the length of a side of a tooth and the body length for each of 6 great white sharks. Tell whether tooth length and body length show direct variation. If so, write an equation that relates the quantities. Okay? So first, what do you think we need to do for this? If I have a table of information, can I just automatically go into this type of equation? Into direct variation. Okay, you can make them like x or y's. I could, yes. I could do that. Here's the thing, though. If I go straight into direct variation and make them x and y's, Melody, then that means I have to do 1, 2, 3, 4, 5, 6 different equations. I want to save us time. Okay, I only want to come up with an equation if I know for sure that this has direct variation. How can I figure out if something has direct variation? What would be the same? In an equation of direct variation, you have y equals a times x. What never changes with direct variation? What is constant? A. A is constant. So if this ratio or number is the same, then I know I have direct variation. So if I set up proportions between all of these and reduce them down or divide them out, and figure out if those numbers are the same, then I can figure out if my constant's the same. If the constant's the same, then I have direct variation and I'll spend my time doing an equation. So what I need to do is take 215 and divide it by 1.8. What do you get when you take 215 and divide it by 1.8? What? 119? What do you get when you take 290 and divide it by 2.4? 290 divided by 2.4. You would get, if I could write this right, that would help. 120, roughly 112, 120.8, so I'm going to round it to 121. Okay, 121. Are those ratios the same? Are those proportions the same? Because the ratios are approximately, well, they're kind of close, aren't they? 119, 121. Okay, so I'd keep going. Do 350 over 2.9. 350 divided by 2.9. you get 121 again, okay? If you do, I don't know, 430 over 3.6, okay, 430 divided by 3.6, you're going to get 119-ish, okay? If you take 565 and divide it by 4.7, okay, you're going to get 120-ish again. And if you take 695 and divide it by 5.8, you are going to get 120, okay? All of these numbers are fairly close. 120, 120, 119, 119, 121, 121. And you're dealing with large numbers. So those are close enough, okay? They're approximately equal, but the data does show direct variation. Okay, an equation relating tooth length and body length, okay? I can take it and I'm going to use the 120 because it's in between the two. And I'm going to say body over tooth length equals the 120, correct? That's what we just did. Body over tooth length equals the 120. So my A is 120, which means my equation comes out to say body equals 120 times the tooth length. That would be my equation for direct variation. Does that make sense? Okay. Now, when you're dealing with smaller numbers, clearly the distance between them needs to be smaller. But if they're within like 2 or 3 numbers, then you can say that they have direct variation when you're dealing with proportions like that. Okay. If you are dealing with straight up like facts about things, and it's not necessarily like a shark experiment, it's the moon over here or whatever, okay? Our proportions need to be very close in order to do that. So it takes a little bit of judgment. Nothing drastic, okay? Questions on any of that? Okay, you're doing direct variation for homework.